Okay, so in the second logarithm video, we're going to talk about the common logarithm and the natural logarithm. So common logarithm, this says that if you have a log base 10 of x, you can write this as just log of x. So anytime you just see a log with no base, notice here there's no base, you can assume that it's base 10 because of the common logarithm. Okay, so for instance, log of 100 equals 2. You can assume that there's a 10 here because 10 squared equals 100. Okay, so invisible here. A natural logarithm, this is written as ln. Okay, so ln of x, this is the log base e of x. Okay, so anytime you see a natural logarithm of x, you can assume that it's log base e. Okay, so recall the rule for inverses. If two functions are inverses of each other, if you compose them, and you both get x, then they're inverses of each other. Okay, so in terms of logarithms, the two important formulas to know, or not formulas, but rules to know, is if you have basically logarithms and exponents are inverses of each other. So log base, if you have log base b of b raised to the x power, notice how these are the same base. This equals x. Okay, this is very important. And then the flip side, if you take b raised to the log base b power of x, this gets you x. These are both very important. Notice that basically this and this cancel out, and this cancel out. What are you left with? X here, and x here. Okay, so let's go over some examples. So we have 10 to the log of 4. Now notice that there's no base here. This is a common logarithm, which means there's a base 10 here. Okay, so I'm going to write it there, even though common logs you don't write that 10. And I'm going to come back to this right here. B is 10 here for our problem, and it's 10 here. So essentially, we can cancel these out, and we'll have my answer. So this essentially cancels each other out. What am I left with? My answer here is 4. Now, I encourage you to pause the video and try the next one out yourself and see if you can get the same answer as me. Okay, so try this on your own. Now, I'm going to rewrite natural log as log base e of 9. And notice I have base e here. Okay, I can do that. Essentially, they cancel out. What am I left with? My answer is 9. Hammermill International Paper. Okay, so we want to do a little bit more tough one. Let's go log base 5 of 25 raised to the x power. We want to simplify this. Now recall our our other rule here. Okay, notice that this and this have to be the same thing. In our problem, it's log base 5 of 25 to the x. Notice that here and here are not the same. But we can write 25 in base 5, so that way now these two are the same. So now let's do that. Okay, so I'm going to rewrite this as log. I'm not changing the value of anything. This is going to change into 5 squared. This is the x power. Now, properties of logarithm states that if we raise a power to a power, we multiply them. So this is going to be log base 5, and then this is going to be 5 to the 2x. Now, I have same base here, inverses of each other, okay? What am I left with? My answer, which is 2x. Okay, so let's try one more. again, I encourage you to pause the video and try this one on your own. 27 to the x power. Okay, so we want this and this to be the same base so that they essentially cancel each other out, so we can find out what this simplifies to. So that means I need to write 27 in base 3. Okay, this means 3 to the what power equals 27. Hopefully you guys recognize that 3 cubed is 27, so I can rewrite this as 3, base 3. Instead of 27, I'm going to write 3 cubed. This is raised to the x power. Again, here's the property of exponents where I'm going to multiply these. So this is going to turn into log base 3 of 3 to the 3x. Now, what happens when I have log base 3 of the same base? Okay, I am left with my answer, which is 3x.